I welcome you back to the fourth lesson. In the previous lesson, we have discussed the discovery of benzene and the methods of preparation of benzene. In the methods of preparation of benzene, we have discussed four methods. The first one was from ethane gas, the second one was from sodium benzoate, the third one was from phenol, and the fourth one was from benzene sulfonic acid. These things must be on your tips. You must inculcate this habit that you should emphasize on learning the schemes, and by learning the scheme itself, you must be able to generate theory lines by yourself. So I want you to practice the methods of preparation of benzene. All those four methods, you should be able to write the scheme as well as 2 or 3 theory lines about it. In today's session also, we are going to cover some kind of chemical schemes itself, and things are going to be more interesting because this session is going to cover the journey when the benzene molecule was not completely known, and in fact its structure was being derived. So that is why the name of the topic is derivation of the structure of benzene. And the schemes that we are going to discuss in this session are going to work like the evidences. Like some crime happens, you try to find the evidence of anything that you want to prove. So in the same sense, the structure of benzene was proved through the evidences that were collected over time. These schemes or these experiments were conducted by different scientists. So that means evidences from different people were collected, and the structure was tried to be derived out of these experimental results. So without further ado, let us jump towards what we are going to study today. The first thing that was discovered was the molecular formula of benzene. The scientists were able to figure out that the compound that they were dealing with had the molecular formula of C6 and H6. That means there were 6 carbons in the compound and there were also 6 hydrogens. So it was way back around 1850s, and people at that time used to pay a lot of attention to the molecular formula itself. So the scientific community, they looked at the formula of benzene, which was C6H6, and they compared it. Compared with what? Compared with the general formula of the compounds that were known till then. As you already know these general formulas, that alkanes has a general formula of CnS2n plus 2. Alkenes have CnS2n, alkynes have CnS2n minus 2, and cycloalkane follows the same formula as alkenes. So when people compare the molecular formula of benzene with these one, they were shocked to see that how can a compound have so less number of hydrogens, because alkanes have twice the number of carbon plus 2 number of hydrogens. That means if benzene is made up of 6 carbons, then if it was alkane, the number of hydrogens should be at least 14. So people compared it. So they were very clear by comparing the molecular formula that benzene is a very unsaturated molecule. That means there is a lot of unsaturation in this molecule. Unsaturation means presence of double bond. This was the first hint. And this presence of unsaturation in benzene molecule was supported by a number of other experiments. So which are coming further, the things which are going to come now are actually the experiments that were conducted, and it was concluded from those experiments also that yes, benzene has unsaturation. Like the first experiment, let us see the first experiment. Here you can see that benzene is heated in hydrogen atmosphere in the presence of catalyst like nickel and palladium, and this is being done at high temperature and pressure. So the benzene gets converted to cyclohexane. Hydrogen gas is actually getting consumed. That means benzene must have double bonds and a lot of them. Only then this much amount of hydrogen is getting consumed. So that also gave the same hint that yes, benzene contains unsaturation. Let us see the second experiment. In the second experiment, some researcher carried out reaction of benzene in presence of chlorine gas in the presence of sunlight. Now in presence of light, the halogens acts as radicals and they get added across the pi bonds of the molecule. So as benzene contains 3 pi bonds, this was not known at that point of time. So anyways, it was known that yes, it must contain some double bonds. So the same happened in this experiment also, that chlorine got consumed with benzene and it formed some other compound with the name benzene hexachloride. This is one important compound. We will study this particular compound as it was a very good pesticide and was used until now in a good amount in the whole world. So we will study about this particular compound, but right now I just want you to focus on this thing, that chlorine was added across the double bond of benzene. So yes, it proved that benzene contains unsaturation. So another experiment that gave the hint in the same direction. Let us see the third experiment. When benzene was reacted with ozone, now this ozone is the same ozone that you keep on discussing, that is the protecting covering of our earth atmosphere. It protects us from the harmful UV rays, and we as human are producing chlorofluorocarbons and other harmful substances which are leading to depletion of ozone. So that is why we are simply exposing us to the harmful radiations of the sun if we do not stop producing such ozone depleting compounds. But right now the ozone is being used as a reagent. Here you can see benzene is being reacted with O3. O3 is nothing but ozone. Like you have oxygen gas which you write as O2, the ozone is written as O3. This is the molecular formula of ozone. And now also you can see the ozone molecules are getting consumed across the double bond of benzene. So one benzene molecule is consuming 3 molecules of ozone. So you can see on each pi bond the O3 has been added across the carbon-carbon atoms. So 3 of them. This complex is known as benzene triozonide. We are calling it ozonide because this is the complex of ozone and there are 3 complexes, so it is being called triozonide. So the complete name is benzene triozonide. Now this complex is very unstable and can break under the presence of any metal and water. So under the presence of zinc and water, this triozonide complex breaks. The green lines which are passing through it is the cleavage line. The cleavage is happening across the line, so it forms glyoxal. So anyways, this experiment also concluded that benzene must contain some form of unsaturation and the pi bonds. Only then the ozone can get added across the double bonds and form triozonide, and this finally glyoxal can form. So 3 experiments supported that yes, the benzene contains unsaturation. Until now that was no confusion at all. But the things were not as smooth as they appeared initially. There were some other experiments also which took the attention into wrong direction or a different direction. The experiments were, as every alkene, anything which contains double bond can react with some reagents and give product. all the alkenes give such kind of products. So when you react any alkene with H2SO4, it undergoes addition across the double bond. The same happens with bromine. If you react any alkene with bromine, the bromine atoms gets added across the carbon-carbon atoms of the double bond. If you react any alkene with KMnO4, which is an oxidizing agent, the alkene carbon double bond carbon breaks and two carboxylic ends are created. So any alkene or any molecule which has a double bond must give this reaction. So it was supposed that if benzene contains double bond, then benzene must also give these type of reactions. It was expected, but when it was verified practically, the answer was no. Benzene does not give many of such kind of reactions which were presumed to be given by any molecule which contains double bond. So this was something confusing. Previously, the experiment suggested that the molecule contains unsaturation, that means double bond, and now the experiments were saying that benzene is not giving the reactions which any molecule that has double bond should give. Let us move to the next experiment. Here, one more experiment was conducted. Now any alkene can react with bromine and the solution of the bromine is brown in color. So if we dissolve alkene in the bromine solution, the alkene finally eats up the bromine and the solution is turned from brown to clear. The solution becomes colorless over time because the alkene eats up the bromine. But when the same thing was done with bromine, that was not the case, and instead eating up the bromine gave some other kind of reaction. And the reaction was substitution reaction. On the top, this reaction is called addition reaction because bromine is getting added across the double bond. But here, there is no addition, but there is substitution. Because the hydrogen atom on this carbon of benzene is getting replaced by the bromine atom. So instead of addition, the benzene gave substitution. This is also depicted by this diagram. Here, you can expect the benzene has a double bond and it should add the Y and the Z positive and negative charges across its double bond. We will look about the positive Y and the negative Z in detail in the later sessions, but you can simply understand from here that anything which is having positive charge can undergo substitution on benzene. That means benzene can give out one of its hydrogen and can add the positive charge atom or group over it. So nothing is getting added across benzene. That was happening in this case. Benzene was not actually going that way. So substitution was favored. In short, I would like to make you understand here is that benzene does not give addition reaction, instead it gives substitution. And which kind of substitution? The electrophilic substitution. It substitutes the positive groups over one of its hydrogen site. So that's it for the evidences for the structure of benzene. In this session we have covered that the derivation in the structure of benzene was done starting from the chemical formula, which was C6 and S6. The formula itself was signifying that there are a lot of unsaturation in the molecule of benzene. This was also supported by various experiments such as this hydrogenation experiment, the halogenation as addition experiment, and the reaction with ozone. But there were some other confusing experiments where benzene failed to react with some oxidizing reagents, and also it was not giving typical addition reactions, it was giving substitution reactions. So these were the evidences which were found while the structure of benzene was derived. Until now things are very confusing, but I want you to follow me up and we will go through the derivation of the structure of benzene and are going to look at three of the most beautiful models that were presented in support of the structure of benzene. So see you in the next lesson.